Hey, George. All right, so I'm looking at number 6 first because on number 7 I kind of skipped this step. But just to point a couple things out, like when you're looking at a limit like this, it's all about growth rate. And it sounds like you understand this one. If I plug an infinity there and an infinity there, because this is an exponential function, exponential functions eventually will exceed the growth rate. And when I talk about growth rate, I'm talking about how quickly they're moving up to the right. This will exceed the growth rate of any powered function. So even though the power might be 45 and it numbers like 100, x to the 45th might very well be greater than 2 to the 100th. But eventually at infinity, this is growing faster. So if it's growing faster on the top than the bottom, then we know that this fraction will approach infinity. Well, what I skipped on number 7 was me actually plugging the negative infinity in there. So when I plug the negative infinity in there, you're like, well, what does 2 to the negative infinity mean? Well, when I look at 2 to the negative infinity, sometimes to me, I've noticed with students, that's a little trickier to think about. So what I like to do is tell them, if you plug a negative infinity in the bottom and in the top, for exponential functions, go ahead and take that 2 to the negative infinity and just make it a 2 to the positive infinity in the denominator. And that way, you can kind of just deal with the positive powered growth rates. So now that's a positive infinity. It's easy for me to see, oh yeah, that's growing really big. See, 2 to the negative infinity is actually growing really small. But people don't think that way. They see that infinity and they go, oh, big, but negative. But 2 to the negative infinity doesn't mean big and negative. It means small. Well, it's easier if you just make those exponents positive, put them in the denominator. Now I have a big negative infinity times a big positive infinity, which is just a huge negative infinity, which really doesn't matter because if the top is constant and the bottom is huge, the fraction's approaching 0. I hope that helps. Tell me if it does not, and I'll try to figure out another way to explain it. All right, see you, bud. And for number 8, it's really essentially the same principle. You probably get it after me talking about number 7, but if I plug a negative infinity in there, again, 2 to the negative infinity, what is that really doing? Well, it's easier to think if I make that 2 to the negative infinity a 2 to the positive infinity on the top. Now I have a huge infinite value here that's positive, a huge infinite value here, but negative, right? Because 45 negatives is a negative, and infinity to the 45th is huge. Well, 2 infinities that are negative give me a negative infinity over a 1, and that would just be a negative infinity. All right, hope that helps.